Okay, section 6, factoring ax squared plus bx plus c. So this is only a very subtle difference. This is only a very subtle difference from section 5. In section 5, basically it was the same exact thing, except there was no a. All right. In section 5, we dealt with just x squared plus bx plus c. So it was a more simplified version. And just to remind you what we did in that section, basically we played a little puzzle game where we were asking ourselves what multiplies to make this last number, what two numbers multiply to make this last number that also add together to make the middle number. Okay. And that only applies if I don't have any number out in front. That was section 5, and that's what we did. And as soon as we found out what two numbers multiplied to make the last number that also added to make the middle, those would essentially flesh out our factors, whatever ended up in the parentheses. Okay, and so that was section 5. In section 6, now we're adding in this fact that x squared is not going to be by itself. There's going to be some coefficient here. So for instance, in these first two examples, you can see automatically that there's something attached to the x squared. This one has a coefficient of 5. This one has a coefficient of 4. And so in this section, we're going to deal with the same sorts of trinomials, x squared trinomials, but we're also going to deal with the coefficient out in front. And that's going to change our process. It's not going to be as simple as saying what multiplies to make this last number that also adds to make the middle. But what's going to involve is a new method that can be a little abstract at first and take some practice. But if you can get this method down, solving these is going to be very straightforward. It's basically going to be a two-step process. And I'll break that down in a little bit. But before I get into solving these guys, I first want to deal with this example, because this is kind of a unique example. Your first several questions on your assignment from section 6 will deal with problems similar to this, in that the very first thing you can do with anything that you were asked to factor, as soon as it says factor, technically the very first thing you could do in general, and it's not always going to be the case, but in this example, the very first thing we can do is simply look for a greatest common factor for each of the terms. In this case, you can see that each of these monomials has a 5 in common. And in some cases, it will be a number that's in common with all of them. In some cases, it'll be a variable. Obviously, this one does not have a variable in common all the way across because this one just does not have one. And then in other cases, you'll have both a number and a letter that you can factor out. But that's technically the first step with any factoring problem, is to first check for any greatest common factor. Do any of these terms share anything in common? In this case, all three terms share a 5 in common. And so jumping to the whiteboard, this first example, we're given 5x squared plus 15x and then plus 10. So this is similar to what you might see on your assignment, what you might see on a chapter 2 test, and then it will simply say factor. Okay, it's not going to tell you factor using this strategy or factor given this given situation. It'll simply say like, all right, factor this guy. And so the very first step you can do with any of these problems that deal with factoring is to first check if each of the terms have something in common. And in this case, all three terms share a 5 in common, meaning that it is a common factor, meaning that I can divide 5 out from the whole thing. This is the process of factoring. And so just to remind us of what it means to factor, factoring is the inverse operation of distribution. Distribution would be like if I gave you 5 times some parentheses, then this 5 would multiply into every single object inside of this parentheses, whatever it may be. Factoring goes in reverse. So basically, I'd have a sentence polynomial like we have here, and I'm dividing out whatever my common factor is. So in this case, my first monomial, I divide 5 out. If I divide 5 out of 5x squared, I'm left with just x squared. And had I distributed this 5 throughout this parentheses and multiplied 5 times x squared, I'd get right back to this 5x squared. Now my next monomial, this 15x, positive 15x, if I divide 5 out, I get positive 3x. Again, checking to make sure I did the math right, one thing I could do is I could multiply this 5 into this 3x to find out that I get right back where I started. And lastly, my last monomial, positive 10, if I were to divide a 5 out of 10, I would get positive 2. And so that is a version of factoring right there, finding the common factor. This is something that we actually came across in an earlier section. You've definitely come across stuff like this before in general. Again, this is just the opposite operation of distribution, is dividing out common factors. And again, in some cases, you may have a common factor of a variable. We don't here because, again, this term does not have a variable. But if you did have a common variable, you'd be able to divide that guy out as well, however many there might be. So technically at this point, we're not done, because now what's inside the parentheses, I have to check if this factors. Obviously 5 can't factor any further. 5 is just a 5. But in this case, now in this polynomial, I'm going to check to see if this can factor. Now, there are no more common factors between the terms, but one thing I want to point out is this is exactly like what we dealt with in section 5. In section 5, we were given trinomials like this, leading term being x squared. And now in section 5, since it's just an x squared, we play this little puzzle game. What two numbers can multiply to make my last term here that also add together to make this middle term? And so we end up with this kind of structure that we learned in section 5. That my trinomial can be factored into 2 other parentheses, and that the reason why I start both these parentheses with x is because if I were to distribute these 2 parentheses together, the x times x would get me right back to the x squared. Okay, so my job here is to figure out, okay, well, what are the missing pieces here, right? And in section 5, we learned that we were taught that like this is going to be some letter P, some letter Q, basically some random numbers, okay, that are not so random, basically. Like whatever value this is going to be and whatever value this is going to be, multiplied together, they're going to make this value, positive 2. Now, conveniently enough, there's only only a couple pairs of things that multiply together give me positive 2, the first being positive 1 and positive 2. But don't lose track of this. A lot of people forget that also the negatives can multiply together to give me a positive. So for instance, negative 1 times negative 2 also gives me positive 2. That won't necessarily apply here, but a lot of people lose track of those negative options. So in this case, positive 1, positive 2 multiply to make positive 2, but do they also add together to make positive 3? Yes. 1 plus 2 gives me 3. And so my fill-in points right here, the 2 values, the answer to the puzzle, what multiplies to make this number that also adds to make this number, would be positive 1 and positive 2. Now, I was asked this yesterday, does it matter which one goes where? The answer is no. I could have put positive 2 here and positive 1 here. As long as I have both those values in either one of the parentheses, then it's a correct answer. And this would be the final factored, totally factored answer right here. Okay, so this one was actually a 2-step operation. First, finding a greatest common factor, pulling that value out. And then now that I'm down to this trinomial, does this trinomial factor? And again, for this one, since it's like what we did in section 5, the x squared plus bx plus c model, I'm asking what multiplies to make this value that also adds to make this middle. Those 2 numbers, the answer to that riddle is what fills in these parentheses. And now I have a fully factored version. Just to point this out, a lot of students tend to forget the fact that they pulled out that greatest common factor at the beginning. That will always tag along because it was factored out from the beginning. And just to kind of point out that this is the correct answer, if I were to distribute and collect like terms from this multiplication, I would progressively get back to where I started. So for instance, if I had multiplied these 2 parentheses together and collected like terms, I get right back to this guy. And then if I were to distribute this 5 into this parentheses, I would get right back where I started at the beginning. Okay, so I'm going to erase that. We're going to now learn a new process. So what happens if I have something like this ax squared plus bx plus c? But now what happens if, like in this example, I don't have that common term between all three. This one was nice and convenient because I could factor out that 5 at the very beginning, and then it looked exactly like section 5, x squared plus bx plus c. But the problem here with this one is that there was no common factor. 4, 13, and 3, there's no common factor beyond 1, and that doesn't help us. But there's no other common factor to divide out at this point, so I'm stuck with this. So what can I do now that I have this ax squared, this other value in front of x squared? So we're going to learn a new method called x method that's kind of paired together with a method called table method. Now, this is going to be very abstract, so I'm actually going to flip back to the section 5 notes to what was in the margin. Again, this is also uploaded onto Google Classroom. This is section 5, you can see, but here in the margin, the reason why I put it here in the margin on the section 5 notes is because technically you can use this in section 5. And had we been in the classroom, I would have introed this in section 5. But given that we're virtual and limited on time, this is more applicable to section 6. So that's why I'm kind of backtracking right now into this margin. But here's what X method does. It's going to be factoring for trinomials. What's a trinomial again? It's a 3-term polynomial, much like x squared plus bx plus c. Now, the reason why I don't necessarily need to use X method for this guy is because, like we learned in section 5, all I have to do is figure out what multiplies to make this last value that also adds to make the middle value, and whatever 2 numbers answer that riddle end up becoming my values inside my factors, whatever P and Q turn out to be, right? That's the answer to that riddle. And so that's all it takes to factor it. But whenever I have a term in front of x squared, whatever that term is going to throw a monkey wrench into what those factors turn out to be, because if there's a number out in front of x squared, then it's not as simple as saying x times x, which would only give me x squared, because if there's some coefficient in front of it, that means that there had to be some coefficient in front of either one of those x's. And that's ultimately what we're solving for using X method. So it's unnecessary for a section 5 type of polynomial, the x squared plus bx plus c, because it's just x squared. Okay, so this method is unnecessary for that, but it will be necessary for what we're doing in section 6. So let me break down that process. Again, it's going to be 2 steps, an X method followed by a table method. Okay, so the orange values here are going to be things that are pulled directly from the original trinomial that I will be given, whatever it may be. Again, these orange values are going to be pulled directly from whatever the original polynomial will be. These blue values are the answer to that same exact riddle that we did in section 5. Basically, these 2 side values will end up being the answer to what multiplies to make this value up top that also adds to make this value in the bottom. Then they're going to end up being used in my table on these little diagonal boxes. And then ultimately, when I get to this table, I'm looking for common factors for the columns and the rows. Okay, now all of that may have seemed very abstract, and it's going to make a little bit more sense once it's actually put in action. But again, what I want to kind of basically break down here is just the structure. There's going to be an X method, and again, the X does nothing mathematically. It's just an organizational structure, just like the table. Okay, it doesn't do anything mathematically beyond just organize things. But what I'm going to do here is when I start with my X, I'm going to fill in the top of my X with whatever my first term is multiplied by whatever my last term is. So in this case, x squared times whatever c is. And again, I'll apply this to some examples in just a moment, but I wanted to just talk about the structure. So the first term times the last term, that's pulled directly, and I'm multiplying them together to get the top of my X method. The bottom of my X is going to be whatever the middle term, the other term was. Okay, positive or negative. Now that I have the top and bottom, and those are pulled directly from my original trinomial, now I'm going to fill in these sides by answering the same riddle. What 2 numbers, and I threw in the X's because we're going to need to use them for the table. If it's more comfortable for you, we're really just looking for the number values, and you could add the X after the fact. But what I'm going to be trying to figure out is what 2 numbers, P and Q. Again, once we actually have a number example, we'll be able to fill in these things more exactly. But P and Q just represent some pair of numbers that both multiply to make the value up here, but also add together to get the value down here. So it's the same question as before we did in section 5. And as long as you're good with that puzzle, it'll be the same thing. Okay, but now we have these two values on the side. Those values we're going to fill in on these diagonals here in this table. Okay, and the sign will matter, so we have to pay attention to that. And again, we have to add the x's in because it'll matter when it comes to common factors. Okay, so these two values here, these two diagonal values, come from answering the riddle, what multiplies to make top, that also adds to make that bottom. Then filling out the rest of the table, this top left box comes from just whatever the first term is. This bottom right box is just whatever the last term was. These two values were multiplied together to give the top of the x right up here. Okay, but they'll be separated now in the table. At this point, now what I'm doing is I'm looking for common factors in both the columns and in the rows. Kind of describing where this comes from. This table right here, you may notice x squared, qx, px, and c, that actually ends up being just the fully distributed version, but not combined like terms version of whatever that process would be. And so now pulling out the common factors is the equivalent of working backwards to whatever the factored version is. Okay. And then so like in this column, I may have just x or some value times x. And what will end up happening is whatever common factors I'm pulling out of both columns and rows here, where these highlighted green and pink sections are, whatever ends up outside of the table here that I factored out, those end up becoming my parentheses. Okay. So that's an awfully abstract way to talk about it, particularly when I'm just using letters and stuff. So let's actually apply it to an example. So let's flip back to section 6 notes, and we're going to do one example today. We're just going to focus on this guy right here. And then Friday we'll attack the other two that we have on these notes. So here we're given this problem. And so this is very typical of what you'll see in both the assignment today and on your chapter 2 test on Friday the 18th. Here we're given this trinomial, 4x squared plus 13x plus 3. So from the very start, this is obviously different than what we did in section 5 because I have a value, an a value different than just 1 or just x squared here for my first term. So I can't immediately use just like what multiplies to make the last term and adds to make the middle. Okay. Second thing is that I can't pull out any common factor. Technically, that would be the first step, but there's nothing in common here. So I'm stuck with whatever this is. So here's where I'm going to use X method. I'm going to just talk through this first, and then I'll jump to my solution sheet. So when you're setting up your X method, for the record, I show more work than what's probably necessary here. I show kind of the process of how to fill out your X and then what it would look like after you did the multiplication between the first and last term here. Okay, many of you could just kind of skip right to this and then do your table. So really it's just a two-step process. Step 1, step 2, and then whatever factors you get, and that's what you've got. But how to fill out this X, on the top of the X again, it's the first term, 4x squared here, times the last term, positive 3. Okay, so that's where that comes from. And then at the bottom of my X, it's just the other term. In this case, the middle term, the positive 13x. Okay, so again, just showing the work, many of you would be able to do this step either in your head or just immediately write it down. But the 4x squared times positive 3 is equal to 12x squared. So again, you may not need to do this step on your scratch work. You can immediately jump to this guy. This top part is just this first piece times that last piece. I go through that just so you can see where it came from. So that's my first term times my last term. And then at the bottom of the X, that's my middle term. Okay. Now we get the same riddle that we had in section 5. Basically, my values on the sides of my X right here, the values on the sides are going to be the answer to the riddle, what multiplies together to give me 12, but also adds together to give me positive 13. Okay, now several things multiply to make 12. But many of you will quickly realize that only one of those pairs of things that multiply to give me 12 also add together to give me 13, and that's 1 and 12. okay? And so that would be what ends up here on the sides. And if it helps you, just focus on those numbers, 1 and 12, and then add X to them on each side. And that's what will end up filling in these diagonals for my table. There's the 1 and the 12. It doesn't matter which one goes where, okay? As long as you get both representatives, right? And then filling out the table, again, this top left box is just my first term. And this bottom right box is just my last term. Again, these two things multiplied together gave me the top of my X. And now that I got to my table, what I'm going to look for are common factors in the column. So for instance here, 4x squared and 12x, I would ask, like, what's the common factor? 4 and 12, I could pull out a 4. X squared and x, I could pull out an x. So my common factor here in this first column would be 4x. And then here, 1x and 3. Well, numbers, the only thing they have in common is 1. And since only that guy has an x and that one doesn't, there's no x that can be pulled up. So the only common factor here for this column is 1. Okay, so anyway, let me jump to the solution sheet so you can kind of see how it's worked out. And then we'll wrap it up. All right, so here is that problem. 4x squared plus 13x plus 3. I talked about how to fill in the x. Top is just the first term times the last term. Bottom is just the other term, the middle term right there. Filling in the sides. Again, I show more work than this. What's necessary. Many of you would jump right to here. Okay, so there's the top again, there's the bottom. And then on the sides, that's just you filling in what two values multiply to make the top, but also add to make the bottom. Again, positive 12, positive 1. Add the x in, because again, that's why it's x squared, and that's why it's x right there. 12x times 1x gives me 12x squared. 12x plus 1x gives me 13x. Okay, and so those two values right there are what go into the diagonals of my table method. First term goes in the top left. Last term goes in the bottom right. And now I'm looking for the common factors. So again, here in this first column, 4x, 4 because of the 4 and the 12, x because of the x squared and the x. That's the greatest common factor in that first column. And then in this last column, like we talked about, the only thing in common between those two is a positive 1. And technically, that 4x plus 1 is going to be one of my factors. And over here on the rows now, 4x squared and 1x, 4 and 1, the only thing in common in this first row is 4 and 1. That's going to be just a 1. And then x squared and x, the only thing in common is just an x. And in the second row, 12x and positive 3, the only thing in common would be a positive 3. And again, what I have here that was pulled out, that's going to be my other factor, 3. 4x plus 1, x plus 3. That's the punchline right there. That's the factored version. That's, again, pulled out from those common factors from my table. All right, so I'm going to stop recording.